bit dry, I agree with you, but you got to know what the hell they mean. Something a little more interesting is we talked about samples. Let's talk about how to pick samples. Some of you guys are like, I don't think you know what the word interesting means. So, all right. Sampling methods. This is really kind of interesting. I know. I got to be careful about my perspective versus normal people. But the ways to pick a sample. The ultimate goal, what's the ultimate goal for any sample? You want it to be what? I don't know if I said this the first day, but random. I love it. And I said this earlier today, but what makes a sample random? Some of us don't know what the word random means. Just watch a few YouTube videos. You know what random means, shut up. What does random really mean? I want to pick it in such a way that everything in the population has a chance to be picked for the sample. Obviously, if there's a part of my population that can never be in my sample's not representative. I can't assume it is. I have to assume it isn't, because I excluded people from the beginning. Maybe. So random means every element in the population has an equal chance to be selected. Does that make sense? I mean, because we want a sample to be representative so that our results tell us something about everybody. This is the best way to get representative data. All right. So let's get more specific. Types of sampling. Let's start with an easy one. This is what's called systematic. Systematic, automatic. Systematic sampling has a system to it. If I take the temperature every 10 minutes, if I take every third telephone off of the assembly line in the telephone factory, right? Telephone. They used to be plugged into the wall and shit. So there's a system to it. Every nth item or every nth something. I don't know how else to say it. Because it could be every nth minute, every nth person. Are you guys cool with the nth? Because it'd be 7th, 28th. Every 40 minutes, I go outside and see how many people are outside my door or something like that. Right? That would be systematic sampling. Every 7 feet, I take a clump of grass to test it for pesticides. Every 7 feet, clump of grass. Yeah. Systematic. I like it. When would systematic be bad to use? When would that be a bad method to use? Well, you want your sample to be random. And actually, if things are randomly positioned, systematic works beautifully. I just kind of gave it away a little bit. What about if on an assembly line, there's this machine, and it has a bottle, and it clamps down a lid, and then it rotates, and then the next bottle clamps down a lid. You with me? Yes. And let's say that the 7th little prong dude on this thing is defective. So that bottle comes in, it goes around, and it goes, and the lid never goes on that bottle. You with me? So it's going to be all over the truck. It's going to be terrible. So if I take every 7th bottle, I'm going to think nothing's working. I'm like, well, that one did 7. Well, 7. Right? Or if I take every 7th, but I don't start with that bad one, I'm going to think everything's great. Do you see what I'm saying? So if it's cyclic, then I don't want to use systematic, because I might overinflate or underestimate what the effect is. Oh, you guys kind of with me? You a little bit with me? Not at all? You lost me at good morning? Shit. All right. So systematic is a good method to use unless there's something like what I just said. There are reasons why we don't always use systematic. All right. The next two are related. These two have the same first step. Holy shit. All right. Is there any other color I can use? Yay. Break population into groups. That's the same first step. Break, pop into groups. Hey, Pop, come over here. I'm going to break you. Ah! So for example, I got a beautiful example right here in this class. Are you all broken into groups? Yes. You're broken into rows, right? Game of rows. I'm going to have you guys fight. Sweet dragons. Nobody watches Game of Thrones? I understand if you didn't watch season 8. Okay, enough of that. Sorry. So you're all broken into groups, aren't you? I could break you into men, women. I could break you into ages. I could break you into if you watch Game of Thrones or not, right? So there's a lot of different ways to break into groups. So let's just say that I'm going to talk about the rows. Stratified. What do you think of when I say strata? Does that mean anything to anybody? Strata? Strategy, I like it. Stratosphere, beautiful. That actually is kind of close to what I'm talking about. I'm thinking about like in geology, which is sort of related to that, is the layers of things across the strata. So stratified is, I want to randomly pick a few people from each row. So in each row I go you and you, and then you and you, and then you and you, and then you and you. Did everybody have a chance to get in the sample? Did everybody have a chance? Yes. What I hate is when the student is like, well, you picked this guy, but you didn't pick me, so I didn't have a chance. You had a freaking chance. Don't look at the sample and go, I'm not in there, so screw all this shit. No. Did you have a chance? Yes. So it is random, but it's more specific. There's a method to it. I love you guys. You're all like, good Lord, let this stop. But come on, it's not horrible. So stratified, break the population into groups. Let's just put 3 up here. And then take sum from all. Sum from all. Take a couple here, a couple there, a couple there. Bam, bam. Looks like dice, but too bad. And that's my sample. Bam. Sum from all. Stratified. Sum from all. Cluster, I would randomly select a row, you and you and you, and then take everybody from those rows. That's cluster. And what does cluster mean? I think about cereal, honey nut clusters, where you want to eat, you can't just eat a piece, you got to take the whole damn cluster. So you take the entire cluster of stuff. That keeps it straight in my head. So stratified, some from each. Some from all. Cluster all from some. Is that still a type of random sampling? If I take this row and the last row, did everybody have a chance? Yes, they did, because I could have taken other rows. And I'll count you as your own row, dude. Yay. All right. All right, maybe. Oh, let's do this one. This would be chunk, and then we take a couple to be in my sample. We take entire groups. Quick, interesting story about cluster. Oh, I just noticed this. I don't know if I'm going to be careful. Hopefully that stays up there. Now I've got you thinking, I'm sorry, is there another scene? I got it. Not to scare you, but I mean, one semester on the East Coast, one of the panels on the lights fell and hit this kid. It was great. I was like, welcome to our college. He was fine, but my God. Anyway, sorry. It's like watching the movie Airplane when you're on an airplane. I'm sorry. What was I about to say? Something. Oh, the interesting story about cluster. One semester I taught this, and this kid in the front row said, doesn't matter where he was, he said, cluster's bullshit. I'm in the military, and we had a problem with clusters. It's bullshit. It's crap. So holy shit, you got to tell me the story. So after class, he told me when they invaded Iraq and they captured Baghdad. A few months after that, they wanted to go in and take a survey to see how different neighborhoods were doing. after that? You guys kind of with me? You guys remember this? You learned about in history? I'm not going to get into if that was the right thing to do or not. But, so what they did was they did cluster sampling. They broke the regions up into neighborhoods, and then they randomly selected. But what they actually did was they said, man, that area is bad. I'm not going to go there. Is that going to bias a study about how things are? Yes. So that wasn't cluster's fault. Cluster is completely valid. But if you don't randomly select, you are destroying it yourself. That's human error, right? That's non-sampling error. That's our mistake. So it came out, the study that came out said everything was pretty good. Because beforehand they said, I'm not going to go there. It's bad there. Well then, holy shit. Okay, maybe. So that was a real story, and that was awesome that it came out. And I'm like, I looked into it. I'm like, holy shit, dude. This is perfect teaching moment. All right. Maybe. And you're all like, they're all bad. All right. There's one last one that's really easy. It's called convenience. I think I said this word maybe. You guys were a convenient sample for that first day's problem we did. Convenience means you don't even try to ensure that it's random. I'm going to use you as a sample of Grossmont students. Well, that's shit. So a convenient sample, I can't trust it. Makes sense. It's not even trying to represent everybody. Yes?
The way you just said, like they decided not to ask the neighborhood.
Yeah, so in a sense that was a sort of convenience. But, because they didn't even try to make sure it was random because they eliminated, but at least they broke it into groups. They did some methodology. It was just an incorrectly applied cluster. But it was convenient for them to not go over there, right? They're like, okay. You guys cool with that? All right. You got to try it out in the homework. By the way, I might as well tell you this. There's going to be a quiz a week from today. On chapter 1. Definition. You're welcome. Yes?
Are these all the definitions that we need to learn?
No. I just want to say that while I'm thinking about it. We got more coming. We're not done with chapter 1 yet. Who designed this hell of chapter 1? I'm sorry. Just a bunch of definitions. Okay. Everybody got this stuff here? I always have this one girl right here. She's like, wait! I'm just kidding. Shut up. All right. Yes?
So convenience just means that we just happen to be in the same area, so that's convenient for the sample?
That's one way to do it. So if I picked the first few people I see coming out of a mall to ask them what they thought about some politician running for office, that's convenience. Because, I mean, are those people even living here? Would they even vote for that politician? I don't even know. They could be visiting. Did they even try to make it random for all the people that could vote? No, I didn't even try. But unfortunately, so many things we see nowadays, so many polls and shit we see, have elements of convenience to them. So I don't know which news channel. No, well, all right, this is a big assumption. I don't know if you watch news in any form. Anybody watch any kind of news? It could even be, it doesn't have to be on TV. Do you guys get any news more than just Facebook, hopefully? Because it could be Russians getting, yes?
I watch it with my mom.
Oh, like one of the major channels news? Okay.
It was like a Snapchat news thing.
There's a Snapchat news thing now.
Yeah.
All right. Facebook news is horrible because it has an algorithm and only feeds you shit that reinforces your own craziness, and then it's crazy. Right? And you're like, don't be calling me crazy. I'm not calling anything crazy, and I'm calling everything crazy. So it's non-discrimination. Anyway, so it used to be the news was the news, and now it's like, well, you watch this news if you feel this way, and you watch this news if you feel this way. It's bullshit. But where was I going with this? What was the question that was asked? Oh, screw it. I completely forgot. So that was an interesting little side note about news. I like it. Somebody did ask me a question, right? Did I answer it?
I was talking about convenience again today.
I went crazy with that, didn't I? Oh, so many polls are convenience polls. And that's what got me to the news. Good Lord, every day I'm more like a little old man. All right. What was I talking about? Okay, what's the last thing I want to do in 1? Okay, we did that. Sweet. Beautiful. So there's one last thing I want to do in chapter 1. And this is actually leading into chapter 2. Yeah, I think it's in section 1.3 that they talk about frequency tables, they call it. We're going to call it distributions. All right. So I'm going to make up some data so that we have something to work with. And we're going to do several things with it. And this is, I sent out an email this morning reminding you guys about the surveys. I desperately need you to fill those in as I get data from those. I'm going to use that data on the first quiz. If I get enough responses, if I don't, I'm just going to use last semester's. I got to use something. All right, so hopefully people can respond to the surveys. Frequency table. So let's start off with some data. Let's say this data, what's something you want this data to represent? I'm not feeling creative this morning. What do we, it could be like the amount of time people wait at a bus stop, or anybody? Nobody's gonna help me out? Huh? Oh, okay, sure. The amount of people wearing black over a month or something, over a few weeks. Not just today, I need several data points. That would be just one data point. So let's say one day there were 4 people, then there were 12. Let me put this in order. 4, 8, 9, 9, 12, 13, 13, 15, 18, 18, 21. Sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sure. Probably. All right. I want to make more data, actually. Sorry. Let's put a couple more. 22, 24, 25, 30. There, put those in there too. Okay. So those represent one day 4 people was wearing black. 4 people were wearing black. Another day 8 people, so forth. So I put them in order to make what we got to do easier. So one thing we're going to do next week is we're going to start getting into the calculator, and the very most basic thing it can do for us is put data in order. It costs $100 frickin' bucks. It should at least be able to do that shit, right? Put these in order, okay. Let me ask you this. If I just said, what's the range of the data? How far does the data range? And let me tell you this. I like what I'm hearing a little bit, but it's a number. It's a number. So it ranges from what to what? 4 to 30, so how far does it range? Beautiful. So what's the range? High minus low. It kind of makes sense. It ranges from 4 to 30, so it ranges over 26, right? Range is high minus low. 30 minus 4, 26. Okay, nothing amazing yet, but that's a new word, and that's the work required for that. Okay, now, what I'm working towards, let me put this up here. My goal, eventually with this data, my goal is going to be this. I want to create this kind of picture. To 30, I want to create a picture that looks like this. So what this picture, this is actually called a histogram. So kind of section 1.3 totally builds up into section 2.1 and 2.2. So I'm kind of doing both. at the same time. This sounds very effective, Jeff. Thank you. Has anybody ever seen a picture like this? Of course you have. Normally what we see are called bar graphs, which is not what this is. It looks like a bar graph, right? And bar graph does not mean a graph showing how much you like different bars in PB or something. So a bar graph would be like, the difference between this and a bar graph is this would be qualitative data. I'm not trying to say anything about Ford and Chevy. I know there's a big thing about them. I don't give a shit about Ford and Chevy. Whatever. But that's a bar graph, qualitative data. Do you see how there's gaps between them? This is quantitative data. If there was a gap, that would mean there's no data there. Like there would have been, if there would have been an empty spot, like right there, that would have meant that there was no time where there's this many people wearing a black shirt. What's the gaps over here mean? Not shit, right? That doesn't mean anything because they're just names. It's not a scale, it's not numerical. Maybe. I'm throwing a lot at you, I know. We're going to get through this. We all right? You guys have all seen bar graphs. I know you have. You probably have seen histograms too. Bar graphs, names, histograms, numbers. No gaps, unless it's empty. Gaps, because it doesn't mean shit. Yes?
So you said that histogram is quantitative?
Quantitative. And bar graphs are qualitative. Okay, I love it. I'm going to try to interpret the looks on your faces, but I think most of it is just tired. Okay. All right. So look at the look of what I'm trying to get towards. I want to go from 4 to 30, but I want to have these bars. And what are the bars going to represent? So when I create a histogram, oh man, what's my only other good one? Blue. We can use 5 to 10 bars, which are actually called classes. So for the size samples we're going to use, this number of classes makes sense, 5 to 10. Okay. So would you say this is a very big sample? Well, compared to what? Compared to normal samples. So Gallup talks to 1,200 to 2,000 people for a sample. With that in mind, is this a big sample? No. So I'm going to use 5 classes. I'm going to use less classes because I got less data to kind of like distribute. Okay, maybe. Stay with me now. So if I use 5 classes and I want to go from 4 up to 30, how wide does each class have to be? So let me give a nice visual. Let's say this is at the 4 mark, right? This is 4 whatevers. And this is at the 30 mark. You guys with me? You have to be, because I haven't done much of it. So 4 to 30, whatever units it is, right? Like mile marker 4, mile marker 30, whatever. And let's say that I love the 70s and I want beautiful wood paneling up here. But I want to use wood paneling. I want to use 5 panels, because that's just like our rectangles, right? How wide, if I want to use 5 rectangles from 4 to 30, how wide would each one have to be to cover the whole thing? Okay, it's a physical problem. It's not even a statistics problem. If I want to use 5 panels, I want to go from 4 to 30, so how far do I want to go? 26. How do you figure out how wide each one has to be? Yes. Yeah. 26 divided by 5 will tell me how big each panel has to be. You with me? So if I wanted to step, how big each step would have to be so that I can take the same size steps and get to the end in 5 steps? I do 26 divided by 5, and that would tell me how wide each step would be so I can get there. That was almost perfect. Yay. All right. Right? No? Yes? Maybe? Very physical. Not some abstract math shit, to be honest. But it relates to abstract math shit. Yay! So what we call class width. Right? This has nothing to do with political ideology about classes. This is just, the class is what we call the rectangles. How wide would each one have to be? It's going to be the range divided by the number of classes. And that should hopefully make physical sense. How far do you got to go? How many things you're going to use to get there? I'll tell you how wide each one has to be. So what do you get? You get 5.26 divided by 5. .2. I knew we were going to get there. Remember the trick about dividing by 5? You double, so you get 52 divided by 10 with the decimal 5.2. Do you want to use 5 point? I don't want to use 5.2. We always take that number and round up so that we overcover. I want to have a place for every data point to go. If I round down, am I going to cover the whole thing? No. Oh, shit. Part of you should feel good. We're sort of getting out of nothing but definitions. And then some of you guys are like, let's go back there. Come on, come on. So see, this picture is what I'm working towards, right? Let me put this back in. So now I know how wide each one of this is going to be so that it covers all the data points. Every data point has a place to go. What do you think the height means? Why would this one be taller in this picture? Because there were more numbers there. So the height is going to be how many numbers fit into that range. So then that's a quick way to see visually. I like to do this for grades. If I do that for grades, it's very quick to make, and I can see where people kind of fell more than other places. I can see if it looks roughly, anybody know what that's called? You're like, a mound. No, it's a hill. A bell curve. It's also kind of a normal curve. Normal curve. Have you guys ever heard the normal curve? You guys ever heard somebody say we're going to curve grades? Yes, and what we do when we say we're going to curve grades, some of us, some of them, some teachers, pick the curve up and move it, right? So like in grad school, I got a 20 out of 41 on the first test, and I thought to myself, what am I doing here? I obviously, and the teacher said, good job, Jeff. I'm like, what the shit? Because the highest grade, I think, was like a 23 out of 40. So I was pretty good, and then if you curve the grades, then the 23 became an A. So I was like an A minus. And you guys with me? You guys know curve. All right, so that's what they really mean. They just pick the curve up and move it. I pick the curve up, move it, and also change the width of it too, but oh well, that's what I do, because I'm weird. Okay, so that again is where we're going towards. Has everybody got this stuff here? We know what the range was, and that went into figuring out what the width, the class width was going to be. Okay. So let's put the classes in. What should the first class start off at? You actually could start off at almost anything, but let's start it at 4. Does that make sense? I could start it at 0, but why? So if the first class starts at 4, what was the width again?
6.
So where should the next class start? 10. And then, right? You guys kind of with me? Again, if the first class starts at 4, I'm going to have the first class go from 4 to something. So that would be whatever this number is here. You guys with me? 4 to something and something and something. I know the next class should start at 10 because the width is 6. Nothing amazing there, right? What's wrong with me putting a 10 here?
Not the right data.
Where would 10 go? Which class?
The
I don't know. So we make this 9. This would be then 15. And then you keep going by 6, right? See that? Keep going by 6, keep going by 6, keep going by 6. Ever see why it's not, you don't see the 6 this way, do you? Right? You see the 6 this way. And I know this sounds like a freaky little detail, but when you start creating these things yourself, this is going to be huge. All right, now finally. This is what they give you this in 1.3. You don't have to make it yourself. But I figured I might as well show you how to make it yourself because you're going to have to do that in chapter 2 anyway. So you're going to give you this shit. And then all you got to do is tally. It's what we call the frequency. How frequently do I see data points between 4 and 9? So what would I put there? How many data points are from 4 to 9? I've had several people put like 5. Why do you think they just put 5? Because they're like 5 numbers. No. How many actual data points are in here? 4. 1, 2, 3, 4. How about here? 1, 2, 3, 4. How about here? 3. Right? 16 to 21. 1, 2, 3. How about here? Was it 3 again? And then here? 1. That's the distribution of data points. That's why I call it a frequency distribution. Yes?
Question, why do we start at 9?
Start at 9?
Why was it 4? Again, the second column, why did you start at 9?
For example, let me see. If I would have, in this particular problem, there's no numbers. If there would have been a 10, and I made this 10, where would 10 go?
Okay.
You might count it twice or not count it at all.
Okay,
Yeah.
Got it.
Now, real quick, now watch. This, stay with me. We're just going to do a little bit more, probably end out early. We're going to go on that field trip. I think I told you guys, right? I'm going to go see my office and the tutoring centers. You with me? And I might let us out early because this is like, this is a lot of shit. I understand. We're actually doing pretty good. We're right on track. But now watch. I don't know. So many people hate this, but a few people like it. There's another way to write this class that's not so weird.